Hello everyone and welcome back. My name is Mr. Koval, and in this video I'm going to go over how to do gas stoichiometry. So let's go into this. So as I've said in previous videos dealing with stoichiometry, the key to stoichiometry is to get to moles. So no matter what unit you're given, whatever substance it is, you got to convert to moles. Why is that? The reason is because you got to convert from one thing to another, and you got to use the mole ratio to do that. You got to use the ratio between moles of one substance and moles of the other substance. And so in order to do that, you got to get to moles. So if they give you grams, you got to convert that to moles. If they give you kilograms, you got to convert that to moles. If they give you liters of a solution, you got to get that to moles. If they give you liters of a gas, you got to get that to moles, right? So whatever it is they give you got to get it to moles. Once you got it to moles, then you can convert your one substance into the moles of a different substance. And then once you do that, you're just converting it to whatever unit they want. Again, if they want liters of gas, and you convert that to liters. If they want grams, and you convert to grams, and so on, right? But the key is you got to get to moles first before you can convert from one substance to the other. So in previous videos, we did mass to mass conversions, right? So using my map here. So if this is the main highway here, grams to grams, right? You could have a mass of one substance. So let they give you kilograms or tons or pounds or whatever. So whatever it is, you convert to grams, and then you can use the molar mass to convert to moles, right? And then from there, you're going to use the mole ratio to convert from moles of one substance to moles of the second substance. And then from there, you go wherever the problem is leading you, right? So if you got to get to mass of this second substance, then you got to convert it to grams, and then whatever unit they're asking for if it's not grams, right? If it's a solution, right? Maybe they'll give you a volume unit of a solution. So you got to convert that to liters first, and then use molarity to convert to moles of the substance. And again, once you're there, right, you can convert that to a unit of mass of whatever that substance is. Or if you want to convert to a different substance, you got to use the mole ratio. And then from there, if they want a unit volume of this new solution or whatever it is, right, then you can go this way. You can use molarity to convert to liters, use the conversion factor, whatever it is, to convert to whatever unit of volume, right? Or if they're giving you a unit liquid volume, you can go this way, right? Go convert that to moles of the second substance, and then figure out the mass of whatever that second substance is if they're asking for mass, right? In this video and other videos where I deal with gas stoichiometry, there we're going to be using the ideal gas law, or any molar volumes that are useful under certain conditions, right? So in this case, we're going to kind of use this pathway here, right? So we might be given a unit volume of a gas. We'll need to convert that unit volume to liters. And then once we get the liters, we could use the ideal gas law to find moles. Once we find the moles, now we're on the main highway here, and then we can use the mole ratio to convert from moles of this substance to moles of another substance. And then from there, go on to figure out what the mass is, or what the other volume of the other substance is, or if it's a gas, or if it's a liquid, what's the volume unit of that? Or if it's a mass, right, we want to find the unit of mass, whatever it is, right? So we follow the roadmap. Okay, so here's an example. So we're given how many liters of carbon dioxide gas at STP will be formed from the complete combustion of this many grams, 82.60 grams of ethanol. Okay, so first thing we need is a balanced equation. That's right. Stoichiometry refers to the use of a balanced equation in order to convert from one substance to another, right? So we need to write out our balanced equation. So we got C2, this ethanol, which is C2H5OH. And then combustion, right? That's going to mean it's going to react with oxygen. and it's going to form, if it's complete combustion and we've got carbon, hydrogen, oxygen, then the only two products are going to be carbon dioxide and water. So we got water plus CO2. So there's our equation. And now we got to balance it. So we're going to start with carbon. We're going to leave oxygen last. So carbon is 2 here. We got 1 there. So we're going to have a 2 there. And then we have 6 hydrogen here. We have 2 there. So we're going to need a 3 coefficient there. And now we have 1 oxygen plus 2. That's 3 on this side. We have 3 plus 2 times 2 is 4. So that's 7 on this side. So we have 1 here. So we need 6 more on this side. So that would be 3 there. So 6 times 6 plus 1 is 7. 3 plus 4 is 7. So now it's balanced. So we have our balanced equation. That's done. Now we can do the stoichiometry. So they're giving us 82.60 grams of ethanol, and they want us to convert to liters of carbon dioxide gas. So where are we on our roadmap? They're giving us a mass in grams. So we're starting here with the grams of substance 1. So what do we need to do? We need to convert to moles using the molar mass. And then we need to use the mole ratio in our balanced equation to get to moles of our carbon dioxide. And then we want the liters, which means that we're going to have to take the moles and whatever conditions they gave us, right? They gave us STP. We'll talk about what STP is in a moment. So that we're going to use those conditions and our PV equals nRT to find the number of liters, which is what they are asking for. So I'm going to show you one way using the ideal gas law, and then I'm going to show you the molar volume way. So I'll do this twice. So the first time, we're going to start with 82.60 grams. So 82.60 grams, and I'll just use ETH for ethanol over 1. And we're going to use the molar mass of ethanol to convert to moles. So the molar mass of ethanol is 46.0692. So 0692. So 0692 grams of the ethanol, 1 mole of the ethanol on top. So grams cancels out. Now I'm here. I got moles. Now I'm going to use the mole ratio in the equation. So methanol to carbon dioxide. So 1 mole of methanol yields 2 moles of carbon dioxide. So it's 1 to 2. So 1 mole of ethanol on the bottom and 2 moles of CO2 on top. So moles of ethanol cancel out. Now I have moles of CO2. Where am I? Now I'm here on the roadmap. So now I want liters of this CO2. So I need to convert moles to liters. So I need to use PV equals nRT. So I'm going to calculate the moles here. So I need to calculate the moles. Okay, give me a second. Yep. All right, so when I calculate this out, I'm going to multiply everything on top, divide by everything on the bottom, and I get my answer of moles. And when I do that, I get 3.5859. So 3.5859 moles of CO2. All right, let me double check that. 3.5859. Yeah. So here's the moles of my gas. Now, what does STP mean? Standard temperature and pressure. Well, what is standard temperature and pressure? Standard temperature and pressure is 0 degrees Celsius and 1 atmosphere. So 0 degrees Celsius, 1 atmosphere is standard temperature and standard pressure. So those are the conditions we got. So we can use our PV equals nRT to find the volume. So PV equals nRT. We want volume in liters, so we're going to solve for volume. So V is equal to nRT over P. Now we just plug in our value. So we're given the number of moles. That's what we just calculated. So that's going to be 3.5859 moles. And R is, we're going to use 0.082058. That's going to be liter atmospheres over Kelvin mole, since we're going to use atmospheres for the standard pressure. And then we're going to multiply by the temperature. Now the temperature is 0 Celsius, but we got to convert that to Kelvin by adding 273.15, which gives you 273.15. So 273.15 Kelvin for the temperature. All of this divided by the pressure, which is 1 atmosphere. So we look at what cancels out. So moles cancels out with moles. So atmospheres cancels out with atmospheres. Kelvin cancels out with Kelvin. And we're left with liters, which is a volume unit, which is what we're looking for. We're looking for volume. So all we need to do now is calculate that answer. And we get 803759. So that's 3759, and that's going to be liters. And so that's the number of liters. Now for sig figs, again, according to the rule of multiplication and division, the sig figs should be the same for the answer. The sig figs in the answer should be the same as the measurement with the least number of sig figs. So here we have 5. Here we have 5. Here we have that's going to be 5, and then we have 1 atmosphere. So this here, where we got this from here. So then how many sig figs does this have? We forgot to go with that one. So we need to figure out what the proper number of sig figs is for this one. So we go back here. So here we have 4 sig figs. Here we have 6. This is exact, so we ignore that. So the answer, the number of sig figs should be 4. So 1, 2, 3, 4. So I'm going to put a line under the 5, which means that the line under the 5 here. So I have 4, I have 5, 5. So the least number is 4. The 1 here, that's going to be exact. We're not going to use that as a sig fig since we got that from STP. So then our answer here should be 4 sig figs. 1, 2, 3, 4. So we're going to cut it off there. And so this would be 80.38 liters of carbon dioxide produced from the 82.60 grams of ethanol that was combusted. Okay, that's the first way. That's using the ideal gas law directly, that equation PV equals nRT. But you should know, and this is going to make your calculations a little bit easier and cut down on the calculations, is that whenever you have STP conditions, you should know that 1 mole of any gas is going to be equal to 24.414 liters. So we can do this a different way. So did I say 24? 22.414. So I'm going to erase this and show you the simpler way. So all of this is going to be the same, but now when I get here, I can use at STP, I can use the fact that 1 mole of a gas is equal to 22.414 liters. Okay, so now I can use that as a conversion factor. This only works under STP conditions. So, and again, STP is 0 degrees Celsius, 1 atmosphere. So, if I pay attention, then I can use this and I can just add that as a conversion factor. So I have 1 mole of gas, in this case, carbon dioxide. So 1 mole of CO2. And then on top, I'm going to have 414 liters. 414 liters of CO2. And now moles of CO2 cancel out. I have liters. And now all I need to do is calculate again, and let's see what we got. And when I do that, I once again get 80.37 liters. So pay attention to the information they're giving you. If they give you STP conditions, then you know you can use the 1 mole of gas is equal to 22.414 liters. If they don't give you STP conditions, then you'll have to use the PV equals nRT to find the number of liters from the moles. And that, ladies and gentlemen, is it for this video. If you enjoyed this video, or if this video helped you in any way, then please, by all means, like the video, share the video, hit that like button. Also, make sure you subscribe to my channel, hit that notification bell. When you do, make sure you click all so you can be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. If you have a problem or a question you want me to go over with you, or show or help you with, if you have a topic that you want me to cover, I would love to do that for you. Thanks for joining me and have a great day.